Hi my dear friends, welcome back to another Python tutorial class. Now in this class we are going to see about some methods of lists. There are some predefined methods available in Python which are dedicated to operate on lists, and we shall see them. So the first one is this pop method. Pop method. What does it say? It says the element at a specific index is eliminated. So if you have a list and there will be an element and that element will have a specific index. So using that specific index, we can eliminate that particular element from the list. Next line is it eliminates the final item from the list by default. So by default, if you do not mention any index position, then this pop method shall eliminate the final item from the list. That's by default. And another important thing is that, another important thing is the removed element is returned. So ultimately, the pop method will eliminate a particular element. Now, if you print that, then you will get that the element that it removes is returned. We shall see it by an example. Here you have a variable L to which this list is assigned 1, 2, 3, 4, 5. The question is remove 3 from the above list. So what do I do is print, then inside print this list, that is L dot pop, and pop is a method. So to access a method we have to use the dot operator, and then for any method in Python you have to give this brackets, that is opening and closing first brackets, and inside this bracket what I'm passing a value which is 2. This 2 is your index position. This 2 is your index position. Okay. So inside the pop method, you have to pass the index position. So what it will do is that it will go to the index position number 2. It will go to the index position number 2, and whatever element is there at that index position number 2, that will be eliminated. So you can easily see that this value 3 is available at index position number 2. At index position number 2 of this list, you have this value 3. So this value 3 will be eliminated from the list by the pop method. And when you give this print, then it will also display out the value which it eliminates. So it basically returns the value that it removes. So if you run this, you see print l.pop2. Here you get 3. Here you get this 3. So when you apply the print function over the pop method, then that print function will display the element that the pop method removes. Okay. And in the next line you have print L. Now in case of this list, you see the value of 3 has been removed from the list. 1, 2, 4, 5. No 3. There is no value of 3 in this list. It has been removed thanks to the pop method. And so a pop method, it eliminates the particular element at a particular index from the list, and you have to mention that particular index. You have to mention that particular index inside the pop method, and it returns the value that it removes, and by default it eliminates the last value from the list by default if you do not mention anything. Like for example, here again you have the same list. L is equals to 1, 2, 3, 4, 5. L dot pop. L dot pop. Now here inside the pop method, I have not mentioned any index position number. So by default, what will it do? It will remove or eliminate the last element from the list. What is the last element from the list? 5. So now if you print L, then you get this particular list 1, 2, 3, 4. You see 5 has been removed. If I slightly come down, then again if I apply this L dot pop, then L dot pop, inside the pop method I'm not mentioning any kind of index position number. So the last element from the list will be removed. Now what is the last element from the list? 4. So 4 will be now removed from the list. Okay. And if you print L, then it will give you this updated list where you can see only 3 elements are there, 1, 2, 3, because 4 has been already removed. Again I apply the pop method on the list, L dot pop. Nothing has been mentioned inside the pop method, no index position number. So that means it will eliminate the last element from the list, that is this 3. This 3 will be eliminated from the list. Now if you print L, hence you get this particular list consisting of these 2 elements, 1 and 2. Then again I apply the pop method on the list, that is L dot pop. So again the last element from the list will be eliminated by default, that is 2 will be eliminated from the list by default. Now if I write this print L, then I get this list having the value of 1. And finally, L dot pop again I apply. Then what will happen? I have not mentioned any index position number inside the pop method, so it will eliminate the last element from the list. This one, this is the first element of the list. This is the last element of the list. This is the only element present inside the list. So this element one will be removed from the list. And when you write this print L, then it will give you this empty list. Okay, you can just try to run this cell again. Yeah. Next we have is the remove method. Remove method. What does it say? The element is used as an input. Here the element is used as an input, unlike the pop method. In the pop method, we had to mention the index position number, but in case of remove method, we have to directly mention the element that you want to remove. So that will be taken as your input, that particular element. And then from left to right, from left to right, it eliminates the element's first occurrence. So from left to right, the first occurrence of the value will be eliminated from the list by this remove method. The next is a value error is raised if the element is not present in the list. Now suppose you want to eliminate a particular value from a list, but that value is not present in the list. In that case, you will get a value error. So here you have L is equals to 1, 2, 3, 4, 5. Question is remove 3 from the above list without using index. Like previously in case of pop method, inside the pop method we were mentioning the index, but now without using index you have to do it. So that means we have to use the remove method. So print L remove, then what value I have to remove? 3. Already it has been stated here that here in case of remove method, the element is used as an input. So directly whatever element you want to remove, that has to be provided here as an input. So that's why L dot remove 3. Directly this value 3 has to be mentioned here inside the remove method, and then it will remove. Now when you try to apply the print function over the remove method, then it will display none, because remove method does not return anything, unlike pop method. Pop method returns the value that it removes, but remove method does not return the value that it removes. Okay. And also for the difference, you can remember that inside pop method, you have to mention the index, but here the question is you have to do it without mentioning the index. You have to eliminate the value of 3. So in that case, directly we can use the remove method, where inside the remove method, you have to mention the value directly, which is this value 3, which has to be removed from the list. If you print L dot remove 3, 3 will be removed, but it does not return anything. Pop method returns the value it removes, but not the remove method. That's why I get none here. Now, if you print L, updated list you get where 3 has been removed. So your updated list is 1, 2, 4, 5. Run this cell. Yeah. Now here you have an example. Suppose L is equals to 1, 2, 3, 4, 5, and you apply this L dot remove 10 inside this list. Inside this list, do you have any value of 10 inside this list? You do not have any value of 10 inside this list. So in that's why we get a value error here. Okay. Already it was stated here that in case of remove method, you're trying to remove a value, but that has to be present in the list. If that value is not present in the list, then it will throw value error, and that's what we get here. Then next, again here you have a list. Okay, and now you see you have these values 1, 2, then 3, then 4, 3, 5, 3, 4, 6, 3, 3. You can see the value of 3 has been repeated here so many number of times. Now print L, we get this same list only that has been created. Now L dot remove 3. L dot remove 3. The basic function of this remove method is it eliminates the first element, it eliminates the first occurrence of the element from left to right of the list. That is the functionality of the remove method. Just for your recap, here has been mentioned that from left to right it eliminates the element's first occurrence. So the job of remove method is to eliminate the first occurrence of the element occurring from left to right of the list. So L dot remove 3. 3 has the value of 3 has been repeated here for so many number of times. Now the value of 3 has occurred in the list for the first time here. The value of 3 has the value of 3 is inside this list, and this is the first occurrence. This is the first occurrence of the value 3 inside this list. At what index position? This is at index position 0, index position 1, index position 2. So at index position number 2, the value of 3 has occurred for the first time from left to right of the list. So if I do this L dot remove 3, then it will eliminate this 3. The remaining 3's will remain intact. The remaining 3 values, the remaining 3's, they will remain intact, and this is the first occurrence of the value of 3 occurring from left to right. So the remove method will eliminate this first occurrence of the value of 3 occurring from left to right of the list. So if you print L, you get this updated list 1 2 4. You see, between 2 and 4 here you had 3, but now this 3 has been eliminated. Directly you get 2 and 4. Okay, then you have again 3 5 3 4 6 3 3. Again, I write L dot remove 3. So what will this remove function do here? It will basically remove the first occurrence of the element from left to right of the list. So it will remove the first occurrence of the value of 3 occurring from left to right of the list. Now from left to right of the list, this is the from left to right of the list, this is the first occurrence of the value of 3. So this will be eliminated. This will be eliminated. When you print L, then you get this updated list. You see 1, 2, 4, 5. This 3 has been eliminated. This 3 has been eliminated. So besides 4, you get 5. Here besides 4, you get 5. Okay. And then again after 5, like here you had 3 4 6 3 3. This will be repeated here 3 4 6 3 3. Again you apply L dot remove 3. So once again what this remove method will do is that it will basically remove the first occurrence of the value 3 occurring from left to right of the list. Okay, so from left to right of the list, the first occurrence of the element, which is 3 in this case, that will be removed by the remove method. So what is that? Which value of 3 I am talking about? This value of 3. You see, 1, 2, 4, 5, then here 3. Then after 4 6 you have 3 3 again, but this 3 basically indicates that this is the here from this value of 3 you can easily gauge that this is the first occurrence of the value of 3 occurring from left to right of the list, and this will be removed by the remove method. So when you print L, you get the updated list. Here you see 1 2 4 5 and 4. Between this 3 has been eliminated. So besides 5 you get 4. So besides 5 you get 4. Then remaining 6 3 3, like that. Okay, just run this. Already ran. Yeah. Then you have the count method. What does this count method do? It counts how many times an element appears in a list. So it basically counts the number of occurrences of an element in the list. Okay, that's what the count method does. It counts the number of occurrences of an element inside a list. So for example, here we have this list L is equals to 20 50 40 10 30 20 50 60 20 30 40 20 50, like this, all these values. So if you write print L dot count print L dot count 30, print L dot count 30. So this will basically count the number of occurrences of the value of 30 inside this list. Okay, so how many number of times 30 has occurred inside this list? 1. Then here you have 2. So 2 times. And so when you run this cell, it will basically give the value of 2. That means 30 has occurred in this list for 2 number of times. Okay, then in the next line, print L dot count 50. So it will basically return you the number of occurrences, the number of times this value of 50 has appeared inside this list. How many number of times? Here once, then here twice, and here thrice. So this 3 is returned here. Okay. Finally, print L dot count 200. Now 200 is not mentioned. 200 is not mentioned here inside this list. There is no value of 200 inside this list. So that's why it returns 0. Okay. These are very important methods in Python. You must remember these. Then you have something known as insert method. What does it do? It states that an element is inserted at a specific index using this method. So if you want to insert a particular element at a particular index of a list, then for this purpose insert method is used. Following insertion, the preceding element at the specific index moves to the right. Now, whenever I'm trying to insert a particular element at a particular index of the list, then that value gets entered at that particular index. But whatever value was before there, whatever value was before there, that will be shifted towards the right of the list. Okay. So let us see by an example. L is equals to 1, 2, 3, 4, 5, 6, 7, 8. Here I'm trying to print L, and here it is insert X at the fifth index. Insert X at the fifth index, and this X is a string value. So print L dot. Here you have the print function. Inside the print function, what I'm doing here is here you have the print function. Inside the print function, I am applying this L dot insert 5 comma X. Okay, L dot insert 5 comma X. So what will this do? L dot insert 5 comma X. This basically is the index position number. You have to mention the index position number at which you want to insert this string value of X. So index position number is 5. So at fifth index position number, X will be inserted, and whatever was there initially at fifth index position number, that will be shifted to right. This is at index position 0, index position 1, 2, 3, 4, 5. So the value of 6 is right now present at index position number 5. Now when I basically run this cell, then this line of code will be executed. Print L dot insert 5 comma X. So here at fifth index position, X will be inserted, that is in place of 6. In place of the value of 6, which is at fifth index position, X will be inserted, and this value of 6, which was initially there at the fifth index position, that will be shifted to the right of X. So when you print L, here you see, first of all, when you print L, then this list will be printed. So here you get this list, and when you print L dot insert 5 comma X, now again pop method returns the value that it removes. Remove method, it returns nothing. Insert method also returns nothing. Okay, insert method also returns nothing. Count method, as we saw, it returns whatever it is doing, but insert method, it returns nothing. It will just do the insertion. So that's why here you get none. Okay, then in the next line, when you're trying to do this print L, then what will happen? 1, 2, 3, 4, 5, and here you see this is the fifth index position. 0, 1, 2, 3, 4, 5. This is the fifth index position where the value of X has been inserted, and 6 was there initially at fifth index position, that has been shifted to the right of X. The remaining remains the same, 7 and 8 here. Okay, 6 got shifted to the right of X, and after 6 you had 7, 8. So after 6 you will have 7 and 8. Okay, so inside the print function, you have to use this insert function. By using the dot operator, you are trying to apply this insert function on this list, that is L, and you have to mention inside the insert function the index position number where you want to insert, and comma the value which you want to insert. Okay, so try to just run this. Yeah. Then again, lst is equals to 1, 2, 3, 4, 5, 6, 7, 8, print L. Now here, L dot insert minus 1 comma X. It means that at minus 1th index position, that means coming from right to left, which is your negative indexing. So at minus 1th index position, I want to insert the value of X. So what is there? What is there at minus 1th index position? This is the value of 8, which is there at minus 1th index position. If you remember, in our previous classes, from right to left when you go, that is for negative indexing. So here the value of 8, it basically becomes the starting value. It lies at index position number -1. This value 7 lies at index position number -2. This lies at -3. This lies at -4, -5, -6, -7, -8. So at minus 1th index position, the value of 8 was initially there. Now that will be shifted to the right of X, because now X will be inserted at minus 1th index position. So when you print L, then you get the updated list: 1, 2, 3, 4, 5, X, 6. Oh, wait a second. Yeah, now we get it. 1, 2, 3, 4, 5, 6, 7. Now here initially at minus 1th index position, if you go from right to left, this was the minus 1th index position. Here the value of X has been inserted, and towards its right the value of 8 shifts inside the list. Okay. Then next you have is the clear method. Clear method is very simple. Just to clear out all the contents of the list, it is used. See here, you see, it makes the list empty by deleting every element from it. So clear method, it is used to make the list empty. It will eliminate or delete each and every element from the list. So here you have L is equals to 1, 2, 3, 4, 5, 6, 7. Then you give print L. Then you give print L dot clear. Since it's a method, for method, you have to give these brackets for any method. Okay. And to access a method, you have to use the dot operator. Now inside clear method, no need to pass anything. Inside clear method, no need to pass anything because it will by anyhow clear out all the elements of the list. So it will make the list an empty list. So clear method, it returns nothing. Clear method returns nothing. It simply clears out everything from the list. So print L dot clear will return nothing. That's why you get none. Okay. In the next line, when you print L, here you get your empty list. Here you get your empty list. Okay. Then moving to the next cell, something very important, that is your copy method. Copy method. What does it say? It creates a new list by copying every element in the original list. By the name only you can guess what it does. Like it copies the values from the original lists from to some other new list. Okay. Now first of all, here's something you have known as shallow copy. Shallow copy. Let us see what it is. Here you have a list 20, 30, 60, 80, 90. Print L, comma id of L. If you do, this list is printed and its corresponding memory ID, that is memory address where it is located, that is also printed. So what is this L actually? Inside Python, we have inherent pointer. That is this variable L. It actually points out to this particular memory address. Okay. This value of L, it actually points out to this particular memory address. And at this memory address, we have this list. Now, in this line, L1 is equals to L. I've written that a new variable L1 is equals to L. So logically, what I'm trying to do is I'm assigning this list to L1 also. Already this list has been assigned to L. Now when I do L1 is equals to L, that means I'm assigning this list to the variable L1 also. Okay. Now if you do print L1 comma ID of L1, print L1 comma ID of L1, then here L1 will also point out to the same memory address. Here you see this memory address is again printed here. So that means L1 points out, L1, it also points out to the same memory address, and at the same memory address you have this particular list. Okay. First of all, print L when you do, then this list will be printed because the value of L is pointing out to a particular address, and at that address you have the value, and that value will be printed. Next you do ID of L. So ID of L means the memory address of that particular list will be printed. When I'm doing print L1, then L1 is pointing out to a particular memory address where we have that list, and that list is printed. And when you do ID of L, then you can see that this same memory address is been printed here. That means the memory address is the same. One memory address you have, same one memory address only you have, and to that particular memory address, L1 is also pointing out. L1 is also pointing out to this same memory address where you have this list. So altogether you have one memory address where you have this one list 20, 30, 60, 80, 90, and L, the variable L is pointing out to this particular memory address. L1 is also pointing out to this same memory address. Okay. Now suppose I want to do some modifications. We know that list is mutable. Once defined, it can be modified also. So what I do is L1 0 is equals to none. That means at zeroth index position of L1, I am assigning this value of none. So none will come in and occupy the list at index position number 0, and it will replace the value of 20. It will replace the value of 20. Now if I print L1, then here you see none comma 30 comma 60, none comma 30 comma 60 comma 80 comma 90. Very fine. I wanted to do the modification only with respect to L1. So there the value of none has been inserted at the 0th index position as it has replaced the value of 20 from the list. Now if I do print L, if I do print L, then here in case of L also you see that the value of none has been inserted at the 0th index position where it has replaced the value of 20. Okay, so whatever is the value of L1, whatever is the value of L1, that same value for L also I'm getting. But that was not my intention. I just wanted to do this modification in case of L1 only. I just wanted to do this modification in case of L1 only, not in case of L. But unfortunately, the modification the modification has occurred for L1, and also by default it has occurred for L also. For L, I didn't want. Why that happened? Because ultimately L1 is pointing out to this L1 is pointing out to this same memory address. This is the same memory address, and at this memory address you have this list, and this 20 has been replaced by none. 20 has been replaced by none. Now when I try to print L, then L also points out to this same memory address. L also points out to the same memory address. Now at this memory address, you have this updated list where none has already been inserted and at the 0th index position where it has replaced the value of 20. So at this particular memory address, L will be pointing, and whatever values there at this memory address that will be printed. So that's why in case of L1 also, in case of L, when I print L, then I get the value of L1 only. Because ultimately L1 is pointing out to this particular memory address, which is repeated here also. And at this particular memory address, you have this list where 20 has been replaced by none. So when you print L1, then you get that none 30, 60, 80, 90. But when you print L, L is also pointing out to the same memory address. Same memory address, you have one memory address only where you have this list, and at that memory address right now we have this particular list, none 30, 60, 80, 90. So when you print L, this list will be only printed again. Okay, so that is one what should I say, that is one disadvantage with shallow copy. Now suppose I want to do this. L1 is equals to 400. That means at 1th index position, at 1th index position of L, I want this 400 value to be inserted. So at 1th index position of L, at 1th index position of L, you have this value 30. So this value of 30 will be replaced by what value? By 400. So when you print L, then you get none, comma 400, comma 60, comma 80, comma 90. Okay. When you print L, L will basically point out to this memory address, and at this memory address, now we will have this particular updated list where 400 has occupied the index position number 1, wherein it has replaced the value of 30. Okay. Now when I do print L1, when I do print L1, then what will happen? L1 will point out to the same memory address. L1 will point out to the same memory address, and at that memory address, I have none, comma 400, comma 60, comma 80, comma 90. So this particular list will be printed again, which has been pointed out by L1. But this modification I did only with respect to L. I didn't do it with respect to L1. That was not my intention also. But unfortunately, since L and L1, both of them are pointing out to the same memory address, hence you have that same list which will be printed again and again, where we will have this continuous updation, whether be it with respect to L1 or L. So in spite of not wanting it, still you see whatever was the value of list printed by L, that same value of list you will get when you print L1, because L1 is also pointing out to the same memory address, and at this memory address you have this updated list thanks to this particular step where we substituted, where we inserted 400 and it substituted the value of 30 at 1th index position, and you had this updated list. Now when you print L1, L1 will point out to the same memory address, and at this particular memory address you have this particular updated list only. So when you do print L1, then this list will be printed again. But that was not my intention. This is shallow copy. This is one disadvantage. That's why we have something known as deep copy. That's why we have something known as deep copy. What happens here is you have a list. L is equals to 20, 30, 60, 80, 90. Print L comma ID of L. So here you have this list. The list will, when you do print L, the value of list is printed. When you print ID of L, the memory address will be printed. So L is actually pointing out to this memory address where you have this list, and that value of list is printed when you do print L. And if you do print ID of L, then that corresponding memory address where the list is there, that memory address will be printed. Now here L1 is equals to L dot copy. Here what we were doing, here we were directly writing L1 is equals to L. But instead of doing that, this will result in shallow copy. L1 is equals to L results in shallow copy. To avoid this, we go for deep copy. Deep copy means L1 is equals to L dot copy. So this is a method. This is a method. So what will happen here is when you print L1, then you will get this same list. When you print L1, you will get the same list as that of L. But now you can see when you do print ID of L1, then the memory address where this list has been created is printed. Now you see this memory address is different from this memory address. This memory address where you have this list is, different from this particular memory address where this new list has been created having the same values. So now you can see that L points out to this memory address where you have, this list, and L1 it points out to this memory address where you have this list having the same values as that of this. So what happens is this particular list has been created at this particular memory ID, and this particular list has been created at this particular memory ID or memory address, and the two memory IDs are different. Inside the list the values are the same, but now two lists have been created. One list is pointed out by L, another list is pointed out by L1. Now if I want to do this, L0 is equals to none. L0 is equals to none means I want to do the modification in case of L only. What modification? At the 0th index position of L, the value of 20 needs to be replaced by this none. And that will happen also, list is mutable. So the value of none will be inserted at the 0th index position of L where it will substitute the value of 20. So when you do print of L, you get this updated list none, 30, 60, 80, 90. This updated list is here at this particular memory address. Okay, so when you do print L, L will point out to this memory address where you get this updated list. Now I want to check whether this has affected my L1 also. I don't want L1 to be affected because I did not want any change to occur in L1. So when you print L1, L1 will basically point out to this memory address, and at this memory address you have this list. Okay, so when you do print L1, then this particular list will be printed again, which is 20, 30, 60, 80, 90. Now you see, in case of L, the modification happened, none, 30, 60, 80, 90, and now this list is different from this list which has been printed out by L1. In case of print L1, you get this list 20, 30, 60, 80, 90, where no modification has occurred. 20 is there. 20 is there intact. It has not been replaced by none. So this is the advantage of deep copy. This is the advantage of deep copy. Then next is slicing is also deep copy. We have already covered slicing, positive slicing, negative slicing, and all. So here we will list L is equals to 1, 2, 3, 4, 5. Print L comma ID of L. If you do, this list is printed and the corresponding memory address where the list has been created is printed. Now L1 is equals to L. Then within the square bracket, I'm applying slicing. Double colon 1. In case of slicing, I have not mentioned any, start value or start index here. So Python will grab it by itself inherently. I have not mentioned any stop value. I have not mentioned any stop value or stop index. So that will be also grabbed up by Python automatically. I have only just mentioned the step size, that is 1. So by default, we know how it will go: 0, 1, 2, 3, 4. Internally, this becomes your 0 is to 5 is to 1. This is the start index. This is the stop index, which is excluded. So Python will go just before the stop index. Stop index 5 is excluded. So Python will go up to 4 in the steps of 1. So first it will start with 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. Okay. At 0 you have 1, at 1 you have 2, at 2 you have 3, then at third index position you have 4, at fourth index position you have the value of 5. So if you do this slicing, this is slicing. L1 is equals to L double colon 1, then this entire list will be, created again, but at a different memory address, and that memory address will be pointed out by L1. Okay, so let us see. Print L1 comma ID of L1. First of all, print L1 when you do, then the same list that we got for L, that same list we get for L1 also. But this time this list will be created at some other memory address. You see, this memory address is different from this memory address, isn't it? So here this list has been created at this particular memory address, as you can see here, and for L1 also you get this same list. So that means the same list has been created again at a different memory address, and this memory address is been pointed out by L1 where you have this list value. Okay, so when you do print L1, it will simply point out to this memory address where you have this list created, that will be printed. And when you do print ID of L1, then to which memory address it is pointing out, that memory address will be printed here. So you can try to do some modification like L0 is equals to none. So none will come in here and will replace the value of 1. So when you print L comma ID of L, then the updated list is printed out here, none comma 2 comma 3 comma 4 comma 5, occurring at this same memory address only. So when you do, first of all, here L0 is equals to none, none will be inserted at the 0th index position of L, and the value of 1 will be replaced by it. So when you print L, when you do print L, then L will point out to this same memory address where it was pointing out already, and there this updated list will be printed out. That is none, 2, 3, 4, 5. And ID of L, if you do, then the ID to which it is pointing out, that will be printed. Now I want to check if L1 remains unchanged or not. Print L1 comma ID of L1 if you do, then L1 will point out to the same memory address. So that same memory address, and whatever value is there at that memory address, that will be printed. So what value was there at this particular memory address? 1, 2, 3, 4, 5. So this 1, 2, 3, 4, 5 will be printed again. Okay, and ID of L1 if you do, so ID of L1 if you do, then the memory address to which it is pointing out, that will be printed. Okay, so here you can see when you do print L1, L1 will point out to that particular memory address where it was pointing out, which is this one, and there whatever value was there, like this list, that list will be printed here, and that list is 1, 2, 3, 4, 5, which is different from this particular list. Okay, so when you print L1, you get this list, which is different from the list pointed out by L. L gives out this list, and L1 gives out this list, and the two lists are now different. L1 has remained unchanged, no modification has occurred in L1. I intentionally applied the modification of L, and there it has been applied successfully. So when you do print L1, then this particular same list will be printed again, and ID of L1, that means to the memory address where L1 is pointing out, that same memory ID or the memory address will be printed again. Okay, now coming down, you have another method known as reverse method. The list is reversed. So here simply reverse method will simply reverse the list. It is not in ascending or descending order. In whatever you have inside the list, that list will be reversed. And again, nothing is returned by it. Reverse method does not return anything. The changes are made to the current list. The changes are made to the current list. So L is equals to 1, 2, 3, 4, 5, 6. Print L comma ID of L if you do, then here you get this list, which is, at this particular memory address. Now if I do L dot reverse, L dot reverse means 6, 5, 4, 3, 2, 1. Here you get 6, 5, 4, 3, 2, 1. Reverse means it will start from here, here, then here, then here, then here, then here, and then here, and to the existing list only the modification will happen. That means at the same memory address only the list will be reversed. So you can see the memory address has remained the same. The memory address has remained the same thanks to this id of L. Print id of L if you do, you can see id you get, and this is the same memory address as that of this one. So right now at this memory address, you have this reversed list. Okay. Then here you have sort method. A list is sorted in ascending order, that is by default. The changes are made to the current list. So let us see. L is equals to, you can see here you have a list 4, 9, 7, 3, 1, 5, 8, 4, 6, 10. There is no order. There is no order here. No ascending order, no descending order. Randomly, arbitrarily, the values have been placed. There is no order. Now, if I apply this sort method on the list, if I apply the sort method on the list L dot sort, then what will happen? This list will be sorted in ascending order. This list will be sorted in ascending order. So if you do print L, you get this list in ascending order 1, 3, 4, 4, 5, 6, 7, 8, 9, 10. Okay, let's try to run this. Yeah. Then in the here, L is equals to 4973158416. Again, you see there is no order inside this list. No ascending, no descending order. Now what I do is L dot sort. L dot sort. What it does, it sorts out the list in the ascending order. Inside the sort method, I've written reverse is equals to true. So at first, what will happen is the sort method will sort out the list in the ascending order. Then it will follow reverse is equals to true. Once the list has been sorted out in the ascending order, then the list will be reversed. Then the list will be reversed. Okay. So inherently speaking, at first by default, this will occur. The list will be sorted in ascending order. Now the list will be reversed. Reversed means 10, then 9, then 8, then this, then this, then this, then this. So in this way, you can do the descending order also with the help of sort method. The trick is inside the sort method, you have to write reverse is equals to true. Definitely, this will be the lowest value, and at the end, you will have the highest value. And if you do reverse is equals to true, once the ascending order has been, once the ascending order has been executed, then if you do reverse is equals to true, now the list will be in reverse order. So definitely now from highest to lowest, you will go automatically, and that's what we get here. 10, 9, 8, 7, 6, 5, 4, 4, 3, 1. The list is in descending order. Just try to, run this, yeah, execute. That is, then here you have something L is equals to 49731584610. Here you see again the numbers, they are not in any order, no ascending order, no descending order, nothing. So if you do this L dot sort, then what will happen? The list will be sorted out in the ascending order. 1, 3, 4, 4, 5, 6, 7, 8, 9, 10. And you get this list once you print L. Now if you do L is equals to L, L is equals to L is to minus 1. L is equals to L is to minus 1. This is slicing. This is slicing, and I'm going in the reverse order. Why reverse order? Because you have minus 1, which is your negative step. So it will start from here 10, then 9, 8, 7, 6, 5, 4, 4, 3, 1. That is from right to left. It will go and simply it will now do this modification. So 10, 9, 8, 7, 6, 5, 4, 4, 3, 1. This is the updated value of the list L. When you do print L, then you get this list. Okay. Now coming down, this is the another method. This is another method in case of list. So index method. What does this index method do? From left to right, from left to right, it gives back the index of the element's initial occurrence. That means first occurrence. So from left to right of the list, the first occurrence, from left to right of the list, the first occurrence of the element will be targeted and its corresponding index position will be returned by the index method. So index method will give you the index position of an element occurring in the list from left to right, but with respect to its first occurrence. Okay. So the very first occurrence of the element inside the list coming from left to right, its particular index position shall be returned by your index method. Index method returns. Okay, just like count returns, pop returns, index method also returns. And another thing, it throws a value error if the element cannot be located. So if the element is not present, then it throws a value error. Let us see. L is equals to this list 4973 1584610. Now, if I do print L dot index 9, inside the index method, I am passing this value of 9. So what index method will do is, inside this list, it will try to locate out the first occurrence of the value of 9 from left to right, which is here. And its corresponding index position, which is 1, shall be returned. So here we get 1. Next is print L dot index 4. Inside the index method, I'm passing this value of 4. So index method will try to locate out the very first occurrence of the value of 4 from left to right of the list, which is here. And its corresponding index position number is 0. That will be returned here. All right. Then here you have print L dot index 4 comma 6. Already in case of string methods, we have used this index method. This index method occurs in the very same way for list also. That is no difference. In case of string methods, we have covered this index method in whatever way it functioned. The very same way it functions for list also. So print L dot index 4 comma 6. What happens here is this 4 is the value, this 4 is the value, and this 6 is the index position from where the index method will start looking out. The 6 is the index position number from where the index method will start searching out for the value of 4. So directly it won't start from 0. Index method won't start from 0. It will directly jump to index position number 6 of the list. So what do we have at index position number 6 of the list? This is index position number 0, 1, 2, 3, 4, 5, 6. At index position number 0, at index position number at index position number 6, at index position number 6, you have this value of 8. Now what will this index method do? It will try to find out the value of 4. It will try to find out, it will try to first of all find out the very first occurrence. It will try to find out the very first occurrence of the value of 4 from left to right, starting from this particular index position number 6. At index position number 6, you don't have 4. At index position number 6, you have the value of 8. But it is from this index position number 6 that index method starts looking out for the very first occurrence of the value of 4 from left to right. So as you can see, it will start its journey from index position number 6 and it will go from here to here. It has the capacity to go from left to right. Starting from index position number 6, it couldn't find out the value of 4 here. Now it moves to the next index position number 7. At 7th index position, it has found out the very first occurrence of the value of 4 occurring from left to right of the list. So its corresponding index position number shall be returned, which is 7. Now if you do print L dot index and inside index method you pass the value of 4 comma, here you have the 5, here you have 5, which is the start index, and comma 10, this is the stop index. Stop index will be excluded, we know. Stop index is excluded, that we know. So Python will go just before the stop index. Just before the stop index means just before 10. Just before 10, what you have? 9. So here the range will be, it will start its journey from index position number 5 till up to 9. Okay, Python will start its journey, that is the control will start its journey from index position number 5 to till up to index position number 9 of the list and will look out for the very first occurrence of the value of 4. That should lie between this range 5 to 9 index position number. So index position number 5, 0, 1, then 2, 3, 4, 5. So at fifth index position, this is the fifth index position from where the control will start its journey from left to right of the list, starting from the fifth index position. At fifth index position, you have the value of 5, which is not 4, because it will be looking out for the value of 4. So at fifth index position, it couldn't find. At sixth index position, it couldn't find. It is the capacity to go from 5 to 9 index position. 5 is done, couldn't find. 6 is done, couldn't find. At seventh index position, it has been able to find out or locate out the first occurrence of the value of 4 occurring from left to right of the list, lying in the range between 5 to 9 index position number. This is the very first occurrence of the value of 4. And what is its index position number? It is 7. And that's what will be printed out here or returned out here. Okay. Now, if you do print L dot index 200, so index method will start locating out, or it will start searching out for the value of 200 inside this list. Do we have the value of 200 inside this list? We don't. So that's why here you will get a value error. Here you get value error, and the value error, it clearly mentions that 200 is not in the list. Okay. You want to try to just run this cell, same results we get only. Okay. So that's it for this class, my dear friends. If you've liked this class, you can kindly hit the like, share, and subscribe button and press the bell icon for notifications. And if you have any comments, you can leave them out in the comment section. I will address them. So thank you.